This is section 3.10, related rates. So this section is all about word problems. Each word problem looks pretty different from the last one, but as we go through this example problem, we're also going to go through a step-by-step guide of how to go through this problem and really how to go through any other problem in this section. So hopefully by the end of the video, you not only understand how to go through this problem, but also have a better idea of how to approach the other problems in this section. So let's go through this example. This is really similar to number 4 in your book. It asks us, at what rate is the diagonal of a cube increasing if its edges increase at a rate of 1 centimeter per second? All right, so step 1 in my step-by-step guide is draw a picture. So I'm going to astound you with my art skills, or lack thereof. Here's my cube. All right, so here's my cube. They don't tell me what the length of each side is, but I do know that since it's a cube, each side is going to be the same length. I'll use this color. Each side I'm just going to label as S. Okay, and you're interested in the diagonal of the cube. The diagonal that they're talking about is this inside diagonal here. So if I were to go from this bottom corner down here all the way up to this top corner, they're interested in that diagonal. All right, so I have my picture, have some things labeled. Step 2, just going to write down my givens. This problem, they really only give me one given, and that's that the edges are increasing at a rate of 1 centimeter per second. Okay, whenever I see the word rate or increasing, rate makes me think derivative, because remember, the derivative is just the rate of change at a specific point. And what rate or what derivative are they talking about? Well, they're talking with reference to the edges. So they're telling me the edges are increasing at a rate of 1 centimeter per second. I can write that as ds over dt equals 1 centimeter per second. The rate that the sides are changing with respect to time is 1. All right, step 3, write down what I'm looking for. They're asking for at what rate is the diagonal of the cube increasing. Remember, I see that word rate again. Rate makes me think derivative. They're looking for dd over dt. At what rate is this diagonal increasing with respect to time? All right, so I have all my givens written down. I have a picture. Step 4, I'm going to write an equation that relates what I have and what I'm looking for. So, pro tip, a lot of times with these types of problems, you're going to have to use a triangle, or it'll be dealing with triangles. Either you might use a Pythagorean theorem, or you might have similar triangles, and you might need to set up a proportion relating the variables that you have. In this case, we're going to use the Pythagorean theorem. Because if you notice, this is the diagonal of a cube, but I can make a relationship of this diagonal with the side here, S, and this bottom part here. Like I just drew a right triangle. I know this side is S. This bottom part, I'm going to label as A, because I don't know the value of this. But using Pythagorean theorem, I can say that my diagonal, which is D, there we go, D squared is equal to S squared plus A squared. Okay, so I just made an equation that relates what I'm looking for, the diagonal, with some of my other variables. But remember, what I'm actually looking for is dd over dt. So I'll need to take the derivative of this equation in order to get an equation that has dd over dt. But looking at what I have now, this equation has 3 variables in it. I don't know how to solve an equation like that. So what I'll need to do is rewrite this equation in terms of just one variable. So how I'm going to do that is, if you notice, this A value right here is actually just the hypotenuse of this bottom right triangle right there. So if we draw that out, this is S, and then my hypotenuse, A. I can use the same relationship and solve for A in terms of S. And then I have A squared is equal to S squared plus S squared, or 2S squared. Solving for A, I get A is equal to rad 2S squared, or I can simplify that into rad 2S. Okay, I have A in terms of S. I can plug this back in to this equation here, and then I'll have this equation written in terms of just 2 variables, in terms of D and S. So let's rewrite that. Now I have D squared is equal to S squared plus rad 2S, S squared plus rad 2S. But remember, this whole thing is squared also. And when I square that out, I get S squared plus 2S squared, which just becomes 3S squared is equal to D squared. All right, so remember, we're looking for dd over dt. But before we take the derivative of this, let's go ahead and simplify it a little bit and take the the square root of both sides. All right, when you do that, now the equation becomes, on the left, you just have d, and on the right, you have rad 3 times radical of s squared, just leaves me with s. Okay, 6 minutes in, and we haven't even done calculus. Let's go ahead and do some calculus. So remember, looking for dd over dt, we're going to take the derivative of this entire thing, see what we have. So on the left here, I'm going to have my dd over dt. On the right, I'm going to have the derivative of rad 3s is just rad 3. I'm going to multiply that by ds over dt. Okay, remember solving for this, but they gave me the ds over dt. That's just equal to 1 centimeter. So when I plug in 1 for ds over dt, I get that dd over dt is equal to rad 3 times 1, or just rad 3. And remember, don't forget our units. The units that they gave us were centimeters per second, so I'm going to keep that in my answer. So the rate that the diagonal is increasing with respect to time is just rad 3 centimeters per second. Okay, so going brief recap through this problem. First 3 steps, I wrote down what they gave me, drew a picture of it. Fourth step, I made an equation that related what they gave me and what I was looking for. But before I could get from this equation into the derivative, I first had to rewrite it in terms of just 2 variables. So I had to find a relationship between a and s. But once I did that, I just solved for d, took the derivative, and then solved for dd over dt, which is what they were looking for. And that was it for this problem. I hope you found this video really helpful. The concepts covered in this video are true no matter what calculus class you're in, but all the sections and problems I referenced were from this textbook right here. And remember that if you're a registered Baylor student, we offer free tutoring on the first floor of Sid Rich. You can either schedule a one-on-one appointment online or just drop in whenever you're available during our business hours for free tutoring. For more information, feel free to visit our website.